And I'm here to talk to you about the water-to-water heat pump system.
Это hardbass, все в спортивках Adidas. И на Nike пацаны слушают hardbass басы. Отожгем для вас hardbass.
So what we do is we put piping in the ground, which we call the geo exchange, and we transfer thermal energy. The ground is normally around 53 degrees here.
British Columbia.
So we're bringing 53 degrees into the house, into one of our units. It goes into a compressor. It's compressed, and as it comes out hotter. Okay? So we can go anywhere from 70 degrees to 105 degrees, depending on what the thermostat and the computer in the unit tells it to do, so that you maintain that comfort level all the time. If you go to Germany, for instance, you cannot build a house unless it's geothermal. They are a lot farther down the line in Scandinavian countries, all through Europe, than we are. They have about a 25% penetration rate.
I don't have to touch it.
With geothermal on all our homes and buildings over there. They also do a lot of solar and wind compared to us. Now let's just take geothermal in
Canada.
We're not even at 1/2 of 1%. And they're at 25%.
This is actually about 400 feet down. At the very bottom of it, there's a pump. And it's going to take that water and pump it up and go into the house where we can use it to heat the building. One type of well is a closed loop filled with antifreeze that circulates horizontally about 5 to 10 feet below the surface. Or you can install the same closed loop of antifreeze vertically into a well that may go down hundreds of feet. The key for any of these loops, though, is that we're always going to find 50-degree temperature both winter and summer under the ground. But that's where the heat pump comes in. We're going to use the basic refrigeration cycle that we see in every window air conditioner, every refrigerator, even to cool our cars, to use that 50-degree water to make your house go. Let me show you. The pipe actually comes into right here. So here's that 50-degree water that's going to come in. It comes across the ceiling, and now it goes right over to here, and it comes down into this heat pump right here. Now inside this heat pump, there's a heat exchanger, and there's the basic refrigeration equipment that we see in every refrigerator or air conditioner. So what happens is that heat exchanger picks up that 50-degree temperature, and now it gets absorbed into the refrigerant. Now when that refrigerant gets compressed and get really hot, that 50 can be 120 or 130 degrees.
Most homes are heated or cooled using forced air systems. Ours is completely radiant, which has the potential to be a lot more efficient.
So we have 2 radiant systems in this home. One is through an activated slab in the concrete slab of the floor. The second is in the sheetrock, or above the sheetrock in the ceiling on the second floor. The hot or cold water that's generated by that machine is circulated by a series of pumps down through the floor, through the concrete slab of the home, and up through the walls and through the ceiling of the second story, where we've actually activated the building surfaces thermally. So we're heating and cooling those surfaces, and the heat then transfers into or out of the space.
Most homes waste a lot of heat, starting with the hot water that goes down the drain. Our home is capturing that waste heat and also harnessing the warmth from the earth.
We're trialing a method that uses a wide bore and only digs down 20 feet. We drop an entire helix of tubing into that bore. When we're making hot water, either for domestic hot water or for heating the house, there's cold water running through these tubes. The cold water is cooler than the temperature in the ground, so it actually picks up heat from the ground and pulls that back to the source side of our heat pump. We're measuring more than 100 points throughout the ground in this field to mark out the temperature distribution, so we can very clearly understand how well this system is exchanging heat with the far Earth temperature. Combine multiple functions and mechanical systems into a single machine. We've deployed here a reversible heat pump that does all of the heating, all of the cooling, and provides all of the domestic hot water for the home.
Три полоски, три полоски, три полоски.
low speed.